Hai, Assalamualaikum warahmatullahi wabarakatuh. My name is Tun Nurisa Sajida binti Ahmad Bakri. My metric number 1201040. So, for today, I'm going to present about the introduction of our presentation. So, what is food microbiology? Food microbiology is one of the study of the bacteria that inhibit, modify, and process food. So, there are many different types of microorganism in it, including the pathogenic type, probiotic, fermentative, and also the spoilage bacteria. So food microbiology is concerned with a diverse range of foods and beverage that are exposed to a variety of environmental conditions. Okay, next, as the title of our presentation, which is Food Microbiology Improving Food Safety and Food Quality, I'm going to explain what is food safety and what is food quality. So food safety is like the process and the condition that ensure the quality of the food throughout the process of the preparation process, processing of the food, and also the storage of the food in order to prevent contamination and foodborne illness. While food quality is like the result of the food safety, which is food quality is the characteristic of the food product that will give profit to the business. It's also provide good value for money, meet the needed requirement, and also the acceptability for the customer. Okay, so in a word, food microbiology is very related to the food safety and quality. It is because the bacteria in the food will enter the food anytime and anywhere. So we have to study the bacteria, either it will contaminate or not the food, to ensure the safety of the food and to prolong the quality of the food for us to consume it.
The next advantages of food microbe in food is dairy product. In dairy product, there are the application named dairy microbiology. Dairy microbiology is the application of various microbiological analysis in the testing of milk and other dairy products, part of which is how to test for bacteria in milk. The microbiological analysis is used to detect, identify, and quantify microorganisms in materials, including food. So, there are many types of microbial trait in dairy products, such as E. coli and coliform, Salmonella, Listeria monocytogen, and Chronobacter. For Salmonella, Salmonella is the pathogen that can affect a wide range of dairy products, including powdered milk and infant formula. Others, such as E. coli, are limited to raw and derivative. For Chronobacter, Chronobacter is the dangerous bacteria that found in dairy products, which can cause severe neonatal infection, including septicemia and meningitis. The next advantages of food microbes in food is probiotic. Probiotics are usually defined as a microbial food supplement with beneficial effect on the consumer. Most probiotics fall into the group of organisms that known as lactic acid that producing bacteria and normally consumed in the form of yogurt, fermented milks, and other fermented food. So there are some beneficial that from the effect of lactic acid bacteria, such as improving intestinal tract health, enhancing the immune system, reducing symptoms of lactose intolerance, and reducing risk of certain cancer. So in probiotic also, there are recent scientific investigation that has supported the important role of probiotic as a part of a healthy diet for human as well as for animal and may be an avenue to provide a safe, cost-effective, and natural approach that act a barrier against microbial infection.
So next, we go to the advantages of food microbes in food. So commonly, we know that microorganisms is function to spoil the food, but they can also be used in the food industries. Food microbes have clearly shown can give a lot of benefits to enhance the safety and the stability in different foodstuff. Food microbes are being utilized for food preservation and food safety. So there are many examples of food microbes that give many advantages to food industries such as yeast and mold. Yeast, or in a scientific name is Saccharomyces cerevisiae, is a unicellular fungus. Saccharomyces cerevisiae is famously known in food production. Commonly, yeast has been used for the production of alcoholic beverages such as beer and wine. Yeast is very important component in the fermentation process, which can convert sugar into alcohols. Yeast also help in the conversion of grape sugar into alcohol and carbon dioxide during the winemaking fermentation process. Other than that, yeast also has its application in bread industry as a leavening agent. So when yeast release gas, which is carbon dioxide, into the environment, it will result in rising dough, which will produce the spongy-like texture of breads and cakes. Yeast are used in the manufacture of single-cell proteins, ethanol, and industrial enzymes in current applications. Next, we go to the mold. So mold is one of the structure of fungi that can grow and spreads on many kinds of damp or decaying organic matter, especially in foodstuff. It is famous with fuzzy and cottony appearance on surface of food. So mucor is one of the mold species that had been employed in food manufacture for generation for cheese ripening and Asian fermented food making. Other than that, Aspergillus mold also involved in food decomposition, and some of them are crucial for the production of fermented foods. Molds also serve essential function in our life by aging and flavoring cheese, as well as being utilized in bread making, fermented liquor, producing soy sauce, producing penicillin, and manufacturing citric acid, which used to flavor soft beverages.
Escherichia coli, which also known as E. coli, is a gram-negative, facultative anaerobic, rod-shaped, and coliform bacterium of the genus Escherichia. It is naturally present in the intestinal tract of warm-blooded animals, include human, and is frequently released into the environment through feces. Under optimal growth condition, Escherichia coli can replicate in around 20 minutes and grow rapidly. In addition to commensal strains, E. coli includes not only commensal strains, but also pathogenic ones that cause a variety of human disease, which resulting in more than 2 million deaths each year. Among the effects of E. coli on human health are diarrhea, meningitis, and urinary tract infection, or we call as UTIs. There are 6 well-studied intestinal phenotypes of E. coli, including Shiga toxin-producing E. coli, or we call as STEC, enteropathogenic E. coli, or EPEC, enterotoxigenic E. coli, ETEC, enteroaggregative E. coli, EAEC, diffusely adherent E. coli, and enteroinvasive E. coli, including Shigella strains. These strains are classified by virulence properties and pathogenicity mechanism, which causing gastrointestinal disease such as diarrhea. Signs and symptoms of E. coli infection usually begin 3 or 4 days after exposure to the bacteria, but we may become ill as soon as 1 day after exposure to more than a week later. Signs and symptoms include diarrhea, which may range from mild and watery to severe and bloody. Second is stomach cramping, pain or tenderness, and lastly is nausea and vomiting. The most prevalent extraintestinal E. coli infection in both community and hospital are UTIs, which are caused by uripathogenic E. coli, or we call it as UPEC or UPEC. It has been reported that 150 million people worldwide experience UTIs each year. A certain number of bacteria present in the urine is referred as UTIs. For symptomatic UTIs, it is classified in order of severity as urosepsis syndrome, kidney infection, and bladder infection. UTIs are more likely to arise in some persons, but they mostly affect the woman. This is because the shorter and closer proximity of the urethra of female to the rectum make it simpler for bacteria to enter the urinary tract. Some of the symptoms of a bladder infection include soreness or burning when urinating, frequent urination, the urge to urinate even when the bladder is empty, bloody urine, and pressure or cramping in the lower abdomen or pelvic area.
Other than E. coli, Salmonella are also one of the food pathogens that affect the food safety. Salmonella is a gram-negative bacteria that presents in gastrointestinal tract of animals and humans. It can spread during cross-contamination, which is during the food preparation or when humans consume undercooked foods. It is regarded as primary pathogen that cause foodborne disease. Salmonella cause outbreak and million people die every year around the world. Dysentery is the example of Salmonella pathogen that cause foodborne disease outbreak. Okay, first Salmonella typhimurium, and second Salmonella enteritidis, and third Salmonella agona. Salmonella enteritidis cause human to having salmonellosis or stomach flu, or known as gastroenteritis, and Salmonella typhimurium cause typhoid fever. Okay, this is the symptoms of stomach flu and typhoid fever. First, nausea and vomiting. Second, bloody diarrhea. And third, dehydration. The symptoms and the disease occurs from 6 hours to 7 days, and if the human does not get in treatments, it will be fatal.
Next, ways to overcome a food microbiology problem to increase food safety. Many countries across the world continue to see high rates of foodborne disease outbreaks. In conjunction with government's effort to maintain the interests of all related parties, particularly involving hygiene and proper food preparation, the Ministry of Health has outlined Food Hygiene Regulation (FHR) in 2009. It was established to protect consumers from foodborne disease and to ensure consumers can enjoy the safe and quality food. The regulations include requirements for registration of food premises, conduct and maintenance of food premises, training, medical examination and health condition, clothing and personal hygiene of food handlers, handling, preparing, packing, serving, storing and selling specific food, carriage of food, and offences. As a result, it is crucial for all food handlers to be aware of food safety procedures and potential causes that can be the source of foodborne disease in order to effectively manage and prevent this disease. So, what are the ways to kill food microbes? For Staphylococcus, it does this by releasing enterotoxins into the food, which leads to food poisoning. Therefore, it is essential to keep foods in the refrigerator, and the use of aprons and gloves by staff members help reduce the risk of skin-to-skin contact. Next, staff members should continue to adhere to the rule of hygiene and minimize the amount of time they spend in direct physical contact with food. Phage typing is a method that can be utilized in cases of staphylococcal food poisoning to ascertain whether the staphylococci that were recovered from the food were the cause of the disease. On top of that, cooking destroys the C. perfringens cells that are actively developing and causing food poisoning, but it does not necessarily destroy the spores that have the potential to proliferate into new cells. Spores have the ability to germinate and give rise to new cells if the food that has been cooked is not promptly served or refrigerated. It is possible that their presence in foods cannot be avoided because the spores of some strains are able to withstand temperature up to 100 degrees Celsius for more than 12 hours. Furthermore, the spores of Clostridium botulinum are resistant to heat, but the toxin that is created by bacteria growing out of the spores in anaerobic conditions can be eliminated by boiling, for example by maintaining an internal temperature of more than 85 degrees Celsius for 5 minutes or more. It is possible that the heat used in commercial pasteurization is insufficient to destroy all spores. As a result, the safety of these goods must be dependent on inhibiting the growth of bacteria and the creation of toxins. Temperatures in the refrigerators, along with high salt concentrations and/or acidic environment conditions, will limit the growth of bacteria and the production of Clostridium botulinum toxin. For the E. coli, the infection is caused by feces that have contaminated water or food. It can be spread by unpasteurized milk or raw or undercooked ground meat. Meat and dishes should be thoroughly cooked to kill E. coli, and no shortcuts should be taken when preparing them. For food safety reasons, it is important to take precautions at every step of the food production process, from planting seeds on the farm through packaging and serving the final product. Cooking foods thoroughly, avoiding cross-contamination of raw and cooked foods, maintaining appropriate levels of personal cleanliness, and maintaining enough levels of sanitation are the most effective methods for managing E. coli.
Hi, Assalamualaikum warahmatullahi wabarakatuh. My name is Misara Rudiah binti Zainal Abidin. My metric number is 1201038. Now, I would like to elaborate more on how to overcome the effect of food microbes to human health. We can overcome this issue by utilizing advanced technology. First advanced technology that I want to highlight is food irradiation. Food irradiation is one of the advanced technology that helps provide better food safety and quality. Food irradiation is used to remove microorganisms that cause food spoilage, similar to the process of freezing, high temperature processing, and chemical processing. This food irradiation does not affect their nutritional value or significantly alter their flavor, texture, or appearance. In fact, the alteration brought about by irradiation are just subtle that it's difficult to determine if food has been exposed to the radiation. By reducing or eradicating microbes, food irradiation or the application of ionizing radiation to food may improve our food safety and increases the shelf life of the food. Now, moving on to the second technology that I want to highlight is the polymerase chain reaction technology, or well known as PCR technology. PCR technology is another example that helps to improve food safety and quality. In food, PCR is used to detect foodborne pathogen and genetically modified organism in food product. This PCR technology is based on 3 simple steps required for any DNA synthesis reaction. The first step for PCR reaction is the denaturation of the template into single strand. The second step is annealing of primer to each original strand from new strand synthesis. And the last step is the extension of the new DNA strand from the primers. By conducting this PCR technique, we can trace any microbes that occur in food. There are other microbes like Listeria species, Listeria monocytogenes, Campylobacter jejuni, Cryptosporidium parvum that may be tested using this PCR technology. There are also more technologies that help us to improve our food safety and quality. But for now, that's all from me. Thank you.
Okay, hi, it's me again, Tunurin Sajidah. So I'm going to conclude what we have elaborate in this slide. So firstly, we have explained about the advantages of food microbes. Food microbe will help in the preserve food and will prolong the shelf life of the food. Next, there are many types of bacteria that will help a lot to food industries, which is Lactobacillus, Saccharomyces cerevisiae, and also Propionibacterium frunderici. Okay, so next, the effect of microbes to our health and food. So there are many types of microbes that exist in the world, but pathogenic microbes will cause foodborne disease. So the example of pathogens that will cause foodborne illness, which is E. coli and also Staphylococcus aureus. And lastly, we have elaborate about the solution for the food microbe issues. So first, we have to follow the Food Hygiene Regulation 2009 made by our government Malaysia. Next, we also can use the advanced technology such as PCR in detecting the foodborne illness. And also, lastly, the most important thing is food industries must take serious precaution in the food handling process. Okay, so last but not least, we as a student, we must spread this knowledge to our community and society. It is because food is our main source in our life, and our food will be easily contaminated by anything. So it is important for us to take part in it to ensure the food safety and quality, and so that we can create a good future in our food industries.